Hello everyone, this is Mohamed Darwish and we get back with another video. In this video, in last few days I was studying the structure, so I get to know the linked list. So I get some, let's say, um, uh, I forgot the word. Anyway, so I made some implementation for linked list, and I mean by some implementation, a simple one. Like I didn't made it generics. I made it just accept the integer data type. Okay. So first of all, let's try to run it. We'll add 15, 35, 16, and add 22 in the first, and then add 15 in the first, and then delete the index 2. Let me just ignore this for the first time. Say, okay. So here we run it. We have 15 because this is the last one we get added or added. Okay. And we have 22, which is here, and we have 15, 35, 60. Okay, let's try to add, for example, insert, add, let's say, an index 2. I want to add, let's say, number 33. Okay, index 2, it should be here after, uh, sorry, here, after 22 and before 15. Let's see. Okay, as we see, we have 33 here. Okay, so now let's try to delete this 33. And here we delete it. Okay, so now let's go to the implementation. First of all, here's the node class. I just made it with two fields, int data, okay, which is the data at int data type, okay, and the node with the second one, sorry, which is next, which will be a reference for the next node in the linked list, okay. And I made it by node data type because then it will be reference for a node object. Okay, and let's go to this. So at first, at linked list class, I made the head node, which will be the first node in the linked list. Okay, and then if we want to insert another node or the data, we'll accept the data by integer. Okay, we can make it later like a generics, but for this I will make it just integer data type. Okay, here in mistake I just need to make it head automatically. I don't need to. Okay, so we will make a new node. Okay, and we'll make data equal to data. Okay, the data of the new node will be the data we get from the user, and the next will be null. We don't really need this line, but I restored it. Okay, if the head is equal to null, so we don't have head, we don't have first node. Okay, the head will be this new node, and that's it. Okay. Else, so if we have a head, we have first node. We want to add the second node, which will be at index one. Okay. So we'll make a new node, we'll call it here n, and we will make it equal to head. Why we don't choose head, uh, let's say, automatically instead of made a new node? Because we don't want to change the head node. We just want to access the last node we have. Okay? Because insert will add the node at last thing. Okay? And then using while loop, while n dot next, which will be the next loop, and then the sorry, the next node, uh, in the node, okay? Because as we talked here, node will have a field called next, which will be a type node, which will be the reference for the next node. So each node will have data, okay, data, and reference for the next node at the linked list. If there's nothing after that node, it will equal null. Okay, so if n dot next not equal null, or while not, n dot next not equal null, n will equal n dot next. So if we are, let's speak as head. We have the head. Okay, we have, let's say, two nodes. Okay, the head and another one. Okay, so the first will be the head. Okay, head dot next, which will be the reference for the second node, not equal null, because it's reference for the second null. Okay, so now the n, which equal head, will be the reference for the second node. Sorry. Okay, so n equal the reference for the second node. And now return back the second node. The next of that second node, does it have a reference for the third node? No, because we don't have the three nodes. We have only two, so it will equal null. So we'll get to that to the second node dot next, which will be the reference for the third node, and we'll give it a node we just made here, which is a new node, as uh, so the next here will be the reference for the new node. Okay, because Java using reference, not pointers. Okay, let's start now. And so as at start, so we'll make a new node and give it the data. Okay, so node dot next will equal head. Okay, and the head will equal node. Why we say that? Because we want to make this new node is the head. Okay, so this new node, his next node will be the head or the old head. Okay, and the new head will be this node. Okay, so this is, for example, this is the new node, and we have an old node which is head. Okay, so this new node, we want to make it the head. So we have to make the second node, okay, is the old head, or this head now. Okay, so let's say this will be the first node. We will make it the first node. So it will be referenced, okay, or has reference the second node reference. Okay, it will contain the second node reference, which will be here the head, and here the head node will be this new node. Okay, I hope you get it. Okay, in the insert at, which will take the index and the data to insert the data in that place. So if the index equal to 0, we'll just call insert at start, because 0 is the head node or the first node. Okay. Else, if the index is not 0, just say for example 2. Okay, we'll make a new node. Okay, because we wanna insert, which will let's say add a new node. Okay, and we'll give the new node data the argument data. Okay, and make a new node which will have head node. Okay, so we can access to the other nodes, because each time we want to get to the other nodes, we have to access the sorry, we have to access the all nodes we have until we get the node we want. Okay, so now the index, let's say it's 1. Okay, or let's say it's 2. Okay, it's 2. So the index is 2, so we want to add here in place of 15. Okay, uh, here we have the head, and we made a for loop instead of while loop, because we don't want to access the last node. We want to access the third node, sorry, because it's index 2. Okay, so I will equal 0, and I will be less than index minus 1. So if index is 2, we will access to the uh, index to the node of index one. Okay, so and of course n dot n equal n dot next is the same old one. We make it at stop to access the next node. Okay, so we now I with 0 and n is head, the head node. Okay, so got the first loop. Now n is equal to the first node. Okay, and now I is 1 and I is less than 1 because n is 2. So we'll not get the second loop. Okay, just have first loop or one loop. Okay, so now n is equal to the first node, which is here. Sorry, second node or node of index 1, which is 22. Okay, let's take this as example. So now node, which is the new one, dot next. This is a new one. You don't have next node yet. We'll make it n dot next, which is 22. Okay, dot next, which will be the 15. Okay, we'll make it equal to the new node because we want to add the new node here instead of 15 and push the 15 to front. Okay, and n dot next will equal node the 22 dot next, the next node of 22 will be equal to this new node. Okay, I think this made it simple. At least I tried to. Okay, now let's go to delete first. It just will equal head dot next. Here's the head one, 15. We don't want it anymore. We want to make 22 is the head. So we'll make head equal the next node, which will be here 22. So this one will be deleted. Okay, and delete at. I think this we don't need it. Okay. Of course, if the index is 0, we'll call delete first. Else, okay, we'll do this stuff. So let's assume as before that index is 2, okay, which will be 15. Okay, so we want to delete the 15. So what we want to do is to get access to 22.next and 15.next. So at first we want to add access 22. So we will make a new node which will equal to head, so we can access the nodes. Okay, and for int I equal to 0. Okay, so I is 0, and while I is less than index minus 1, which will be in this time 2 minus 1, 1. So we get one loop here. So we get to the first node, which is second node, sorry, which is 22, or the node of index 1. Okay, then the node, we made a new node, sorry, which is n will equal 22.next, which will be 15. Okay, just a minute. Let's go back. We get the first one, head, and head equal next. So we get access to 22. 22 dot next. Node dot next will be equal n dot next. Wait a minute. I think I uh just a minute. So the first loop we had head. When it finished, we got the node of index 1. Node 1. Okay, which here is 22. Okay, so the new node we made will equal 22.next, which should be 15. And the node.next will be equal n.next. So the node is the 22 dot next. Oh, okay. Okay. Oh, now I get it. So we want to access to the 25, uh, 35, sorry, which will be in the 15 dot next. So the new node we made will make it equal to 15, okay, which is node, which here node is 22, and dot next we get into access to 15. Okay, so the node we will use here will dot next, which is 22 dot next, will be equal n, which is 15 dot next, which will be 35. Okay, I hope you get it. So now, last one, which will be show. I think it's easy. Make a new node which equal to head and access as the insert while node.next not equal null is out the node.data. Okay, and node will equal node.next, and after it we'll make also node.data. We'll point it again because here we'll stop when we access the last node, but we'll not print it because we get access so it equal null. It's next will equal null, so the condition is false, so we'll not get into this implementation in the while loop, so we have to print it out. And that's it. uh, I'll upload the code on GitHub if you would like to, let's say, download it, change it, do some stuff with it. It's your choice. The repository link will be in the description. Thank you for watching. Bye bye.